Hi, Multi. This is my way of making sure that the net change from our class today is a little bit more positive. So all I'm going to do is go over number 80 and 84 from your textbook that were questions today. So please read this, okay? And Christina, and who else wasn't there? Christina and Mark. What I also asked students to do for homework is to please type and then print a comment for me telling me how your experience in the class has been going so far. I want them to be kept anonymous. I really do not care about the identity of the feedback giver, but please type them out, print them out, and then tomorrow when you come to class, or Friday rather, hand them to Matt, and Matt's going to shuffle them all up and give them to me. So again, you're giving me some feedback on how the class is going for you. And Mark and Christina, if you missed our class today, which is Wednesday, we spent an unusual amount of time on the bongos question. And the biggest takeaway for me is I'm never going to use bongos ever again, no problem. Okay, here's number 80. So this one you'd be really careful. And what's interesting is this question, it appears in the gradients and directional derivatives question, which I guess is fine. I mean, and you could have dealt with this question any number of different ways, but I chose to use the chain rule. So what's important is to recognize this is the function. H is the temperature as a function of the number of miles north, which is y, and the number of hours after midnight. Okay? And you're told that a moose runs north at 20 miles per hour. So just look at my purple for a second. So here's the thing. They tell you the moose runs north at 20 miles per hour. In terms of rate, this is the moose's dy dt. All right, because y is the miles north. So if the moose is running north at 20 miles per hour, this is dy dt, which is interesting. The question is asking you, at what rate does the moose perceive the temperature to be changing? They're asking you for what is dh dt. Now, the key to this question is recognizing the correct relationship between dh dt and dy dt. And this is where this little tree diagram is very helpful. More and more, you'll find that questions that can be, as we move along in multi, questions can be done a variety of ways. This is, I think, the most intuitive. So h is a function of y and t, but for this moose, y is a function of t. If at the end of the game your goal is to get dh by dt, look what you have to do. You have to take care of dh by dt, add it to dh dy times dy dt, and then here are just my values, okay? And at the end of the day, the moose is perceiving the temperature to be changing at a rate of -6 degrees Fahrenheit per hour, or the temperature is dropping 6 degrees per hour as he heads north of the Canadian border, which actually makes some sense, unlike the bongo question. Okay, here's 84. I think the question was A and B were fine, but what's C? I just did the whole thing. So 84, you're given this function, you're standing at this point. If you choose to climb in the direction of steepest ascent, what is your initial rate of ascent relative to the horizontal distance? That answer is going to just merely be the magnitude of the gradient at 1, 1, which is where you are. And here I am just finding the general gradient, and here is the magnitude of that gradient, which is radical 3 units per horizontal distance you travel in this direction, okay? B is saying if you decide to go straight northwest, notice here is my unit northwest vector. Will you be ascending or descending? And you'll see my work here. I have u dot del f, and that's going to be a positive number, so you will ascend. When you're asked to find what is the rate of ascension, it is right here. 5 over radical 2 units per 1 horizontal traveled in the direction of this vector, northwest. Then part C is saying if you decide to maintain your altitude, maintaining altitude means your directional derivative in the direction you head in, it should equal 0. In what directions can you go? Well, we know del f at 1, 1 is -2, 3. If there's a vector such that v dot del f equals 0, then v indicates the direction for altitude maintenance. I just made that phrase up. That just means you're maintaining altitude, which means your change in altitude is 0. So there are two possible directions. Okay, there are infinite possible vectors, but here are my two directions, either this direction or this direction. Either of these dotted with del f will equal 0. So those of you who had a question on 80 and 84, These should now be fully answered. That leaves us with a net positive gain from class today, unless you consider a gain going into the worldwide vortex of the ridiculous, namely bongos. Good night.